Hello everyone, I'm Monika Bhushan and today we are starting lecture number 9 of differential equation. Okay, so in today's class we are going to learn the PI of type 5. Okay, so till now we have seen type 1, type 2, type 3, type 4 and this is the last type which is type 5. So I think we are by now 100% confident that by looking at these equations, these differential equations, we will understand that the solution of these differential equations are nothing but finding out CF plus PI. So this we are actually seeing in all classes, right? So in type 1, we have discussed in much detail that why we have to find CF and PI and how we will understand that the solution is nothing but CF plus PI. Fine. So today we are just focusing on type 5, that how we will recognize that the solution of this differential equation will come under type 5 of PI. Okay. So fine. So we know that PI is what? PI is my YP and yp is what? The right hand side, whatever is present in right hand side, I'm just writing down 5x divided by whatever is present in my left hand side, the differential operator that we are writing down in denominator. So y double dash, we know, right? This is nothing but d2y by dx square. This is degree 2 and this is plus 16y is x sine 3x, or if we write in terms of differential operator, it is nothing but d square plus 16 and then y is x sine 3x, right? So we know these things. So we will understand that why this right hand side is saying that we have to now think of type 5 of PI, because we know that finding PI is nothing but just pointing out that what is my right hand side function, right? Okay, so since we have covered all those types, so we'll just start with saying that whether this is my type 1. So no, this is not type 1 of PIY, because this right hand side should contain exponential term, right? E raised to x if present in right hand side, so it will be my type 1. Okay, fine. So this is not type 1. So whether this is my type 2, so in type 2, yes, trigonometrical function should be present. I can see trigonometrical function, but only trigonometrical function like sine ax or cos ax or sine ax plus b or cos ax plus b or sine square cos square. That means whatever you are going to have the right hand side in type 2 should be variations of your trigonometrical functions only. We can see x also. Because of this x, we are saying this is not even type 2. Okay, now we will move further that whether this is my type 3. So in type 3, what we had seen that my type 3 should contain polynomial function, right? Polynomial term should be present. So we can see here trigonometrical is also there. So this is not my type 3. If only x was there, suppose x is also a polynomial term or x square plus 3 or something, it was your polynomial. So this is not even my type 3. Is it my type 4? So in type 4, what we had discussed in last class only, that type 4 should contain e raised to x for sure, but not only e raised to x, along with that the multiplying factor should be some function which is in terms of x, right? So if it was instead of x, if it was e raised to x, correct, if it was e raised to x and then sine 3x, then yes, it was your type 4, because e raised to x should be present, or you can say that sine h ax or sine hx and sine 3x, this is also your type 4. Why? Because sine hyperbolic is nothing but exponential only, or cos h ax is also your hyperbolic. This is, you can write in terms of exponential, right? So we can say that this is not even type 4. So we have not seen this type. So this is actually type 5. And why we are saying this is type 5? So now we are going to learn the property and how to recognize this is my type 5. Okay. Now, so if my differential equation has right hand side as in this form, this is the general form, then we will call that this is my type 5 of PI. So what is this general form says? That you must be having x present there. Okay, so x I'm writing because we are just considering that the variable is with respect to x. So this is x always there, right? And then v, this format actually we had seen in type 4 also, that instead of x it was e raised to x, and then v is what? V is any function or any term which is with respect to x. Okay, so this Vx could be having variations. This x into Vx divided by Fd. Okay, fine. So this is my type 5. Again, what all things should be present in Vx? The same way what we had discussed in last class, that can I say that x into 1 divided by Fd. So is it my type 5? Because this is x into something divided by Fd. But this is not my type 5. Why? Because 1 is not with respect to x, right? No. Here some function should be present, some term should be present where some x should be present. 1 is not my function of x. So we can say that this is nothing but actually x divided by Fd. Can you tell me what is this type x divided by Fd? This is actually type 3. Why? Because this x you can write in terms of polynomial, correct? No? I'm starting with all those variations of Vx, that Vx can contain which all functions. So if I'm starting with type 1 case, okay, that means if you think that x into e raised to x is present and then Fd is there. So what type it is? So always you start with type 1. So you will now only you will say that this is not my type 1 because this e raised to x is there along with some x also, right? So this is not my type 1. Whether this is my type 2, no sinusoidal function. Whether this is my type 3, polynomial you can say, but along with that some other function is there. This is not my type 3. Whether this is my type 4, yes, this is my type 4. Why? Because in type 4 we have said that you can write this is e raised to x and then vx divided by Fd. So this is your type 4. Vx, if I think that Vx is nothing but some trigonometrical function, right? The type 2 trigonometrical function. So right, now I am saying here this is my right hand side is x sine x. So what type of pi is it? Is it my type 1? No, no any exponential term is present. Is it my type 2? Sinusoidal is there. That means trigonometrical function is there, but not only trigonometrical function. So we'll say this is not my type 2. Is it my type 3? Polynomial I can see, but not only polynomial. So this is not my type 3. Whether this is my type 4, I cannot see any exponential function. So this is not my type 4. Is it your type 5? So yes, this is your type 5. Why this is my type 5? Because you see the general form of type 5. So type 5 has x, then some function which is with respect to your x. So x is there and then vx is sine x and then divided by fd, right? So this is my type 5. Now just think of polynomial, the type 3 polynomial function. Suppose x square plus 1. This is polynomial in terms of x, correct? If I write down this way, and then this is your fx. Now tell me what type of this function. So before moving to this function, I'll just solve it, right? This is, I can write down x cube plus x divided by fd, or even I can split this term, right? So if I'm splitting it, then I'll write down x cube by fd plus x by fd. Now tell me what type is it? So this is your type 1. No. Why? Because exponential term is not there. No trigonometrical term. So this is not my type 2. Yes, this is my type 3 because this is polynomial in nature, right? Even this term, this is also your type 3 because polynomial in nature. So this is your type 3. Okay, if I write down Vx with respect to my type 4, if I try writing down in that way, so now what all I can think of, this is x, then Vx if I write in terms of type 4 case, so this is your e raised to x, and then it could be anything, right? If I write down here, if I write down x only, right? So Vx in type 4, and then this is your fd. So what is this type? So because e raised to x and then any function will be present with e raised to x. So this will be your type 4 only, right? I can say that in my type 5 of pi, what can be present along with this x? you will always be having some trigonometrical function will be there. Okay, some sine a theta, cos a theta. I mean, if I'll talk about x, sine x, cos x, sine square, or any variations of sine, cos, or trigonometrical functions will be present, and then it will be your type 5. Even this type of form is also my type 5 of pi, x raised to n cos ax by fd. Okay, so it is not only x, this is not only x, this could be x square, x cube, or anything. Okay, so similarly, if it is x raised to n sine ax by fd, so we have some formula for that. So if it is only x to the power 1, so what is the formula for that? If only x is multiplying with vx something, so we are going to solve this pi with respect to this method. That is what we are writing down. You can, to memorize it, you can say v by fd. I have just separated, and then what I am going to do here, instead of just x, I am just writing down x minus f dash d divided by fd. This is only the method, this is only the formula. So what will be done here, we'll see with the help of example, we'll see that how to solve. So this, to memorize what we can think of, this we have separated, and then x is getting separated with f dash d by fd. Okay, now if the power of x is not 1, the power of x is 2, 3, 4, anything, and if x to the power 2 or 3 is actually multiplying with cos ax, so what will be my answer? So x to the power n cos ax by fd, if form is present, so I am going to solve this pi with this method. This is what? This is real part. Real part of what? You can see that here e raised to I ax is present. E raised to I ax can be written as cos ax plus I sine ax. Correct? No, these things we have seen. So if it is your cos ax plus I sine ax, so this is my real part, and with I, whatever is present, this is my imaginary part. Correct? And this complete form is called as complex form, and complex number is actually having two parts. One is my real and the second is imaginary. So with I, this is imaginary and this is your real. So real is cos ax and imaginary term is sine ax. So if it is x raised to n cos ax by fd, you are going to write down real part of, you are going to multiply e raised to ix with x raised to n by fd. Okay, this one, x raised to n by fd, because cos ax is what? Cos ax is real part, correct? No, or cos ax is what? Cos ax is real part of e raised to ix. Okay, so this way you can memorize, right? Now if it is your x raised to n sine ax by fd, so what you are going to write down here? So you are going to write down e raised to iax, but imaginary part of e raised to iax, which is actually multiplying with x raised to n by fd. Correct? No? So this will solve using example, then it will be much more clearer. Okay, suppose this is my first question. So what is written if I am writing down this in terms of differential operator? This is d square plus 16y equals x sine 3x. Okay, so by now we understood, right, now that the solution of this given question, suppose this has come in your exam, so if you have to solve it, you understood by looking at lecture number 5 and so on, that the solution is nothing but finding out CF and then finding out PI. Okay, so how to find CF? So first step we had seen writing down in this form of differential operator. Second step is writing down auxiliary equation, and third step is what? Based on the nature of the roots of auxiliary equation, we are writing down the CF. And complete solution is, we know YC plus YP, and YC is only my CF and YP is PI. So these things we know, right? Now, after that, we are going to find what is my YP. So YP is what? We know that YP is nothing but writing down whatever is present in my right hand side and then dividing it by whatever is present in my left hand side, okay, in the form of differential operator. Okay, so this is my YP. Till now, we have not done anything with respect to type of PI. We have just followed the step what we have to always follow in any type of PI. Now I'm going to find out that which type of PI is. And we know that finding out the type of pi depends only on the numerator of yp, right? There is no rule of denominator when we have to think of which type of pi it is. So again, we have seen this thing, right? This is not my type 1, type 2, type 3, type 4. This is my type 5. Why type 5? Because this is x, and then this is vx, v with respect to x, divided by fd. So yes, this is my type 5. So now, if I understood this is my type 5, so now I have to start working on it. And when I will think that I got the solution, when my yp will be free of d, will be free of d in the numerator or in the denominator. That means we have written down yp. Okay, now once we got that this is my type 5 of yp, so what I am going to do, I am going to use the formula x v with respect to x divided by fd equals v by fd, just separated out right now, v by fd. Instead of x, what I am writing down, x minus f dash d by fd. Okay, that means what this step says me, I'm writing down fd is what, just write on the denominator fd we know that fd is d square plus 16. So I'm writing down here d square plus 16. Here this is derivative of fd, that means d by dx of d square plus 16. Okay, so d by dx of d square will give you 2d, and then constant will give you 0. So it is 2d by d square plus 16. Now we are just writing down vx. What is my vx? So vx, that means if you are not considering x, so what is there? So this is sine 3x. So I'm writing down here sine 3x divided by again fd. So I'm writing down d square plus 16. Okay, so same thing actually we have written down here. Okay, now you just focus on this term. So this gives us some clue right now that this is your a fresh pi, the pi of type 2, right? This is your pi of type 2 because this is a sinusoidal function is there. So what we will be doing in type 2? So d square will be replaced with minus of a square, correct? No? So a is 3. So that means d square is going to be replaced with minus of 9. Right? So I'm going to write down minus 9 plus 16, and then it will be sine 3x in the top, right? So fine. So if you will see here what we have done. So this is x minus 2d by d square plus 16 as it is, and here sine 3x, and then same what we had said. Now what we are going to do, this is x sine 3x divided by 7 minus 2d by d square plus 16, and then sine 3x divided by 7, correct? Now what I am going to do here, this x sine 3x by 7 is actually free of d. You can't find d in the numerator or denominator, but the second term you see that d is present. Okay, so first what I am going to do, this is your d by dx of sine 3x. If you will see this numerator, this is nothing but d by dx of sine 3x, and in denominator you write down here 7 into d square plus 16. And again if I write down, what does it mean? This is nothing but 2 d by dx of sine 3x will give you how much? Cos 3x, and then into 3. And this is 7, this is d square plus 16. And further if I write down just the second term, I'm writing down this is 6 cos 3x divided by 7, and then d square plus 16. Okay, now again we know that this term is actually free of d, but here I am finding out d is present, and even I can see that this is nothing but my type 2 of pi, correct? Because exponential function is not there, this is not my type 1, but this is my type 2. So again we'll follow the method for type 2. For this only, if I'm writing down 6, writing down here, and if it is my type 2, so what should I do? 6 by 7 I'm just keeping outside as constant with negative sign. This is my cos 3x divided by d square plus 16. And what does it mean? Minus 6 by 7. If it is my type 2, so what I am going to do, I will replace d square with minus a square. What is your minus a square? 3 square, so 9. So instead of d square, I am going to write down minus 9, then this is plus 16, and the numerator has cos 3x. That means this is how much? Minus 6 by 7 cos 3x divided by again 7, right? So 7 sevens are 49. So this will give you minus 6 by 49, and here cos 3x. but you will not find any d operator. That means you got this term also free of d operator. So this is finally your pi, correct? So yp you got x sine 3x by 7 minus 6 cos 3x by 49. So you can find here, right? So this is same what we have also got, right? So your complete solution is how much? Complete solution is yc plus yp. Don't forget to add yc also, right? So yc we have written down, plus we have written down yp, whatever we have got. So that yp is present here. So we have actually written down here 7 by 49 because taken 49 common, or you can separately write down these two things anyway. This is okay. Okay. Now we are going to see the second question, and why we have written down in terms of 1 and 2, because if you will find solution of this type of questions, actually the complete step is same, only the last step is different. Suppose you got in your exam this question, either this is your x square cos x or sine square or x square sine x. The complete method is same, only the last term you are going to write down. This is your for cos x, this is for your sin x, okay? And what will be the term? We had seen this formula, right? If the power of x is more than 1, if it is x square, x cube or anything, and with that if you have cos ax by fd, so this how we are going to solve? We are going to write down the real part of e raised to I ax and x is x to the power n by fd. And if it is your sine ax, that means x to the power n sine ax by fd, it will be everything is same, just imaginary part. So finally you have to write down e raised to x, x to the power n by fd, you have to solve, and then just the real part will be your answer of cos, and the imaginary part will be answer of sine wala question, okay? Fine. So now we are starting it. We, by looking at the question only, since we have seen all those classes, we know that the answer they are asking is nothing but finding out CF plus PI, and the reason we have seen in lecture number 5. Okay, so we have started with CF. So this is your complementary function. Step 1, writing down in D form. Step 2 is what? Writing down auxiliary equation, and step 3 writing down the YC. This much is done. Now, what is your YP? YP, I am just writing down right hand side, whatever is present, and then left hand side in terms of D operator. So, D square minus 1. Okay, so this is my YP. Now, my job starts that what is this PI, right? First step is find out PI. Second step is then follow the method with respect to that PI. So, we understood this is not type 1, not type 2. Critical function is there, but x square is there. Type 3 is also not there, x square is there, then trigonometrical is not also there, correct? No, not type 4 because exponential is not there. Yes, this is my type 5. Why this is my type 5? Because this is x raised to n, and then cos ax, a is 1, n is 2. I'm going to write yp as, this is nothing but real part of, I'm seeing the formula. So this is real part of what it is. This is your e raised to I ax, a is 1, so e raised to ix, and then this is x raised to n, so x raised to 2, correct? No, n is 2, x raised to 2 divided by fd. What is my fd? D square minus 1. Okay, now what I have to write down? Use the formula, the method of type 4 of pi. So type 4 of pi says what? Write down the numerator as it is, and in the denominator you replace d with d plus a. And what is my a here? The a is whatever is present as power of e. That means with x, whatever is present, this is my a. So here my a is I. Understood? No, the a is I, because in my type 4 we say a is whatever is present on top of e. So this is I. So we are replacing d with d plus I. So I'm writing down d plus I whole square minus 1. Or what does it mean? This is nothing but numerator as it is I am writing down, and the denominator is a square plus b square plus 2ab, and then minus 1 is there. Okay, and we know that iota square is minus 1. That means this is real part of, this is e raised to ix, and then x square, and then this is d square plus 2id, and then this is minus 1 minus 1 minus 2. Okay, Now what next we do? If we remember that in type 4 what we had said, that this e raised to ax we will keep on adding. That means I can write down this term. If I'm writing down here, this is real part of e raised to ix, okay, and then what, this is your x square and this is your d square plus 2id minus 2. That means this e raised to ix, in last class only we had seen that we'll keep on adding till my answer, okay, and we have to work on this part. This is nothing but now my fresh pi. This real part actually at the end, at the last step only, we will just write down what is the real part of this form and what will be the imaginary part if it is in case of my sine theta or sine x, okay. So what we have done till now, just keep on adding real part e raised to ix, and we are going to work on this. Tell me, what is this pi? So is it my type 1? No, no exponential, not trigonometrical. This is my type 3. Right now, this is my type 3 of pi. I'll be doing the polynomial division here. So I have seen in my type 3 of lecture that polynomial division we perform. Before that, we follow that if the function in the numerator is polynomial in nature, then the numerator should be, the power of x should be in descending order, and the power of d in the denominator should be in ascending order, correct? Now, so we had seen this. So this only one term is there, so no ascending descending. In the denominator, yes, I can see that this is my descending order. I have to change it into the ascending order of power of d. So I can write down here minus 2 plus 2id plus d square, okay. So now I'm ready to do polynomial division. Fine. Okay, so now we are going to start polynomial division. Okay, so we know that here I have to write down denominator. So denominator I have written down in ascending power of d, correct? No, so this here we have written down, and here we are writing down the numerator. So numerator we have written down. Now what my job is, I have to write down something here, because this quotient is only my answer. This is only whatever I'm going to getting, this is my pi. Okay, so what is my a? Something I'll write down so that I should get here x square. For sure I need to write down here x square. For that I'm checking what should be my a. So what I can write down with the very first step only, okay. So I'm going to write down minus 2 of a should give me x square. Fine. So a should be x square by minus 2. Fine. So that means I got what is my a. So I am writing down here a is nothing but x square by minus 2. Fine. So this x square by minus 2, actually what we are doing, the very first term I am multiplying with x square by minus 2, which already I have done, then only I am getting x square. So I got x square. Fine. Now next what I have to do, I have to do the operation with second term and then x square by minus 2 also. That means I am going to do now here is 2i of d of x square by minus 2. How much it is going to give me? So first I'll cancel out this 2 and 2. Okay, this is nothing but minus I d of x square, or I can write down minus I d by dx of x square, or minus I 2x. Fine. So I got that this is nothing but my minus I 2x. Going to write minus 2ix here, correct? So whatever I got 2id of x square by minus 2, I'm writing here. Fine. Now next what I have to do? I have to perform d square of x square by minus 2. And whatever I'll get, I'll write down here. Fine. So I'm finding out what is d square of x square by minus 2. So I'll keep out minus 1 by 2, and this is d of dx of x square, correct? So what does it mean? This is nothing but 1 by 2 d of x square is what? This is going to give you 2x. D by dx of x square will give you 2x. Or you will write down how much? This is minus d by dx of x, that is minus 1. So you are going to write down here how much? Minus 1. Fine. Now what I am going to do? I am going to cancel it out. So this is now 2ix plus 1. Fine. Now next what my job is? Again the same thing I am going to perform. Down here a. Okay. So that minus 2 of a should give me 2ix. Okay. So for that what should I do here? So for sure here I need 2ix. So I am going to write down minus 2 of a equals 2ix. So what is my a? A is nothing but minus ix. Okay. So this a, instead of a, I am going to write down how much? Minus ix. Okay. So this minus ix, actually when I am performing with minus 2, I am getting here, right? So that actually we have done. Now what my job is? Now I have to perform 2id of minus ix, and whatever I will get I will write down here. Okay. Now going to perform 2id of minus ix. Okay. So that means I am writing down minus 2, and then this I and I will give you I square, and then this is d of x. Is that okay? So I square is minus 1, so minus and minus will become plus 2, and then d by dx of x will give you 1, so this is nothing but 2. Okay, so here I got 2. Fine. Now what I have to do? I have to perform d square of minus ix. Correct? Now what I have to do? D square of minus ix, and whatever I will get, that I will write down here. But we had seen in type 3 that whenever I am going to perform d square of anything, here it should have power more than 1, that means 2 or more than 2, so that it should give me sub answer. If the power of x is less than 2, if it is 1, 0, then it will give you 0 only, correct? To get some answer, it should be having power of 2 or 3 or 4 or something. So I'm straightforward writing down here 0, and then what I am going to do here? So this is nothing but minus 1. Okay. So when I'll stop, when I'll understand that I got my answer, when the remainder will be 0. Okay. So when the remainder is 0, I'll understand that my answer has come. So now what I have to do? Again I am following the same method, that I am going to write down minus 2 into a. Okay, minus 2 into a should give me minus 1. That means minus 2 into a should give me minus 1. That means a is nothing but 1 by 2. Okay, so that means instead of a, I am writing down how much? I am going to write down, this is plus only, right? Okay, this is plus only, plus 1 by 2. Okay. So here I have to get minus 1 only. Because of that only I am doing it. So that means minus 2 of 1 by 2 is nothing but minus 1. Okay. Now next what I have to do? I have to perform 2id of 1 by 2. So 2id of 1 by 2, that means 1 by 2 is nothing but constant. So what I am going to get here? I am going to get here 0. Correct? So minus 2id of 1 by 2 will give you 0. Similarly, d square of constant will give you 0, and finally you got how much? You got 0. So if you got the remainder 0, so this is only your pi. You got here the answer. So what you have got here? You got x square by minus 2 minus ix plus 1 by 2. Okay. So if you will see the question, so here we also have got the same question here. We had said that we will keep on writing, and then this is how much? This only we have got. Okay. So finally actually we are very near to the answer. What we are finding out here? This e raised to ix. This right now still I am writing down real part. Real part of e raised to ix. Now I am writing down e raised to ix in form of cos x plus I sin x. And when I should write it? When I find that my complete function is free of d or is free of 1 by d. If you will not find d or 1 by d, then you will start finding out that what is your real part and imaginary part. Okay, so I got here e raised to ix is cos x plus I sin x, and this is nothing but 1 by 2, 1 minus x square minus ix. This is imaginary part and this is real part. Now again, real part of what? This we are just opening, right? This is nothing but 1 by 2 cos x, right? 1 by 2 cos x, 1 minus x square plus x into sin x. And when we are writing down x into sin x, because this, if we'll find that this is minus ix, okay, and then plus I sin x. So this is I and minus I, it will give you minus I square. Minus 1 will give you plus 1. So plus x sin x, okay. Now what I'm going to write down here, plus I, because this one, this I'm writing down plus I 1 by 2 sin x, then 1 minus x square, and then minus how much, because I is there, right? So no, this one we are doing, so cos x and then minus I x, this is nothing but minus I x cos x. That means we are doing nothing, we are just opening this completely and then the real part writing aside and then imaginary part writing aside. Okay, so what is your answer? Your answer of this question is real part of this much. So real part of it, this much, is what this is. Okay, so this is only your YP of this question, because this term is my real part and this term is my imaginary part. Okay, so this will be actually answer of when sin x will be given to you. So that means that the second question's answer is this imaginary part. Okay, so my answer here, if I'll see here, the required YP is nothing but 1 by 2 cos x, whatever is present in my real part. So the complete solution is YC plus YP. So YC we had found, and then YP is this real part of whatever we had expanded, right? Now, the second question, you remember that it was the same thing, but instead of cos, it was sin x, okay? So now, if I have x raised to n sine ax fd. So I'm going to follow the same method, but instead of writing real part, I'm going to write imaginary part. Imaginary part was what? Imaginary part of this one was this, correct? No? So this is only my answer of if it is x square sine x. So here y is complementary function is still same, and just instead of this term, I'm going to write this one. So if you find this class useful, please like and subscribe my channel. Thank you.